Hello everyone. Hi everyone, welcome to Deeksha Vedantu YouTube channel. I'm your physics teacher Aditi, and today we have started this live once again for 20 most repeated questions, PYQs exactly. Hi everyone, am I audible and visible to you guys? Hi Alia. We'll just wait for a few minutes so that everyone can join, okay? Hi, hello Alia. Let everyone join so that we can start this live. Today we are going to do 20 most repeated PYQs for CBSE boards. Jasmine ma'am is for bio, Alia. Today we are going to see for physics, okay? Okay, can we start this live? Okay, so in today's live we are going to see two chapters. In last live we saw what? Electricity and magnetic effects of electric current. Now in this today's live we'll see chapter light and human eye. Okay, we'll see most repeated PYQs from these two chapters. Okay, hello Banti Kushwaha. Okay, let's start the live. Let's go to our first question, which says, okay, read the first question carefully and let me know the answer. Read the first question very carefully. A beam of light is incident through the holes on side A, emerges out of the holes on the other side of the box as shown in the figure. Okay, which of the following could be inside the box? Concave lens, rectangular glass slab, prism or convex lens? Let me know the answer in the live chat. A. Alia is saying A. Everyone else? Ma'am, I'm not. My name is Vikash. Okay, Vikash. Okay, what answer is A? Okay, Vikas is also saying A. Alia is also saying A. This is concave lens. Concave lens. Think again. I want you to think again. What lens is this? Concave lens diverges or converges, and what is happening inside this box? Okay, let me give you the answer, guys. The answer is actually convex lens. The answer is convex lens. See, concave lens, what is the main difference between concave lens and convex lens? This is lens. Okay, so convex lens converges the rays, correct? It converges the rays, and concave lens diverges the rays. That is correct. Now if I had a concave lens, what will happen? This is my concave lens. If rays will come, they will go for something like this, right? They will go and they will diverge in opposite directions. But I can see all the rays are coming out from one single point. How will that happen? If I have a convex lens, do I have another? Yes. If I have a convex lens, then only if my rays are coming parallel, they will converge at one point, then only they can travel something like this, right? If I have a concave lens, the rays will get diverged. And if my box just have this one hole, how will this ray come out of this hole? Okay? Correct? Hi Piyush. Convex lens. It's actually convex lens. Okay? Correct? Understood everyone? Was there any doubt? Did your doubt got cleared or not? Now you understand the question? Understand it and read it carefully. Inside the box all the rays are coming out, but if there was concave lens, then how will this ray come out from this hole? Correct? Okay, let's move on to the next question. Second question, read it carefully again. This is a simple good question. Read it carefully. Read the second question. The path of a ray of light coming from air, passing through a rectangular glass slab. Now we are given, this is our rectangular glass slab. Okay, this is glass slab. Now traced by 4 students A, B, C, D in figure, which one of them is correct? B is correct. Anyone else? Bunty is, Vikas is saying B, Alia is also saying B. Okay, both of you are correct. The answer is B. Whenever we have a glass slab, first the ray will bend towards normal, then again it will bend away from the normal. So exactly the pattern depicted by B student. Correct? Okay, easy question. Let's move on to the next one. Name the type of lens that can be used as magnifying glass. Read it carefully. Type of lens. The type of lens that can be used as magnifying glass. Give reason and draw a ray diagram. Just tell me the lens that is used as ray diagram, that is used as a magnifying glass. Give reason and draw ray diagram to support your answer. We'll draw the ray diagram first. Let me know which kind of lens is used for magnifying glass. What kind? Convex lens. Alia is saying convex lens. Anyone else? Let me know the answer in the live chat, guys. Anyone else? Okay, Bunty. Oh, sorry. Vikas. Okay, for magnifying glass, the first thought you should have in your mind is that for magnifying glass, I should have a larger image, correct? The image should be larger, the larger image. And immediately I know that my concave lens never makes larger image or always form diminished image. Always form diminished images. Okay, so from here I know that the answer for magnifying glass is convex lens and not concave lens. Correct? Till now we are sorted till here. Okay, now they are asking for you to make a ray diagram. So what we can do, let me just clear this once. Okay, so the answer is convex lens. Convex lens. Now for ray diagram, if I have a convex lens, where should I place my object to form a larger image? Beyond C maybe, but that will be a real image. Okay, so if you even place your object between, when we use magnifying glass, we tend to place our object very near. Okay, so between pole, if you make this image, so you will get an image something like this. Okay, and this will be your larger image. Correct? Let's move on to the next question. Okay, next question. Question 4th. An object placed at a distance of 30 centimeter. An object placed at a distance of 30 centimeter. So my U is minus 30 centimeter in front of a convex mirror. Remember always which kind of mirror or lens is given and then see carefully if it's a mirror or a lens. Of focal length 15 centimeter. 15 centimeter. Now we know the focal length of convex mirror is what? Positive or negative? The focal length of convex mirror is what? Positive or negative? Then we have to write 4 characteristics of the image formed by the mirror. So the focal length of this mirror is positive. Okay, of convex mirror the focal length is always positive. Now you can either solve this question or you can use your brain very cleverly. Okay, see, the object is at 30 centimeter. Let me calculate the center of curvature for this. The radius or center of curvature will be 2 times of focal length. 2 into 15, that will be 30 centimeter. Now you can either choose this, but you have to be very careful on what kind of mirror we are using. If it was a concave mirror, we could have directly said that after calculating the radius of curvature, u is at radius of curvature, so we will also be at radius of curvature, and hence our question is solved. It will be of same size, real, inverted, whatever. Okay, but this is for concave mirror. Concave mirror. Correct? Now we are given convex mirror. We are given convex mirror, and we know if we place my object, if we place my object at any point between my pole and infinity, that means that my image always forms between pole and focus. Correct? If this was a concave mirror, your thinking will be different, but here it's a convex mirror, so your thinking will be different. Correct? Yes. Vikas is saying like, yeah, correct. U is minus 30 centimeter, F is 15 centimeter. Now we have to write 4 characteristics. What will be the 4 characteristics of this image formed? First will be that it is formed between pole and focus. What else? So you can easily write, right? For convex mirror, image is always virtual. It's always erect, and it's always diminished. Perfect. Correct. Can we move to the next question? Give me a thumbs up so that we can move on to the next question. For this question or these kind of questions, see carefully what kind of mirror you are using, and then according to the object position and kind of images they are making, you have to answer this question. If it was a concave mirror, we'll answer something like this, but it's not a concave mirror in this scenario, it's a convex mirror, so we'll answer differently. Correct? Okay. Hi Trev, good afternoon. Okay, let's move on to the next question. This says, 5th question. Read it carefully. It's not that hard. Keep your pen and paper with you. It's not that hard. It's very simple. Read it carefully. The refractive index of a medium X with respect to medium Y is 3.2. The refractive index of medium Y with respect to medium Z is 3.4. So we are given 3 mediums, 1, 2 and 3, X, Y and Z. The refractive index of X with respect to Y is given as 3.2. Refractive index of Y with respect to Z is given as 3.4. Correct? Now, the first question says, the refractive index of medium Z with respect to X and ZX. We have to find this. Okay? What will be? Okay, Alia is saying 0.0919 is the answer. For the first part, Alia, is this for the first part? Okay. The first part says we have to find the refractive index of two medium Z with respect to medium X. Do you know how to calculate this? I have asked you to keep a pen and paper with you so that you can solve the questions, okay? Again, light From light you will get plenty of questions. From human eye you won't get, other than power you won't get any numerical to solve, but you will have theoretical questions and conceptual questions on defects. Okay, let's see the answer. For nz, it will be nz divided by nx, that is refractive index of z, medium z with respect to x. Now, what can I do to solve this? Okay, let me just multiply this and see what happens. Nx divided by ny into ny divided by nz. What we need to do, we need to cancel out y here, correct? This much we understand. So to cancel y, here y is in denominator, here it is in numerator. So we can just multiply these and it will get cancelled, correct? Now nx by ny is given as 3.2, ny by nz is given as 3.4, correct? This will come out to be, I guess, 10.88, but this comes out to be nx divided by nz, nx divided by nz, and this is nxz, that is refractive index of medium x with respect to refractive index of medium y. Hello GW Fire E. Hello everyone, hello. Okay, now since this is the reciprocal of what we want, we can just write this is nx by nz, this is nx by nz, which is 10.88, but we want nz by nx, so I can just reciprocate it, correct? Nxz, what did we have? Nxz, right? Yes, it was 10.88. So for nzx, we can just reciprocate it, 10.88, and Alia was correct, it will be 0.0919. Okay, this is the refractive index of medium z with respect to medium x. Correct? First part is done. Let's move on to the second part. If the speed of light in medium x, read it carefully, if speed of light in medium x, that is Vx, is 3 into 10 raised to power 8 meter per second, then what will be the speed of light in medium y? Answer is 9.6 10 raised to power 8. Okay, Alia is saying 9.6 10 raised to power 8 meter per second. Okay. Yes, okay, I'm seeing everyone's answer. Everyone is correct. Okay, let's see. So, nxy. Okay, to calculate the speed of light in medium y, correct, and Vx is given. So, we can just do what? We can use the formula of nxy. Since nxy is given, correct, nx divided by ny, this was given, and the formula of velocity with respect to the medium is reciprocal, correct? This formula is correct. Now nxy is given as 3.2 equals to Vy, we have to find, Vx is given as 3 into 10 raised to power 8. 3 into 10 raised to power 8. So if we just cross multiply, we'll get Vy as 3.2 into 3 into 10 raised to power 8, which will be 9.6 into 10 raised to power 8 meter per second. Correct? Understood? Everyone was correct. 9.6 10 raised to power 8, Alia was correct. Okay, moving on to the next question. Study the data given below showing the focal length of concave mirrors A, B and C. There are 3 mirrors A, B and C, and their focal length is given. The respective distance of the objects placed in front of mirror is also given. So we are given with F and we are given with U, and the mirror is what? It is concave mirror. It is given in the question, so read it very carefully. Correct? Now what we need to find, in which case they are asking, in which one of the above cases the mirror will form a diminished image of the object. In which of the mirror will form a diminished image of the object? Let me know your answers. In which case, or in which of the mirror will form a diminished image of the object? Mirror A, mirror B, or mirror C? Can anyone answer this question? Who can answer this question? In which of the above cases the mirror will form a diminished image of the object? Okay, let me give you a hint. We have a concave mirror. So first draw a concave mirror. This is my concave mirror, correct? In first case the focal length is 20, 15 and 30. Okay, let's draw 3 mirrors we can draw. First, second and third. So the focal length is 15. Here the focal length is 20 and the focal length was what? The focal length was 30. Okay, the focal length was 30. Now they have given the position of object. So position of object is 45, 30, 20. It will be, so in this case it will be even beyond, see, somewhere here this will be my object, 45 centimeter. And then second case the object distance is 30 centimeter, or yeah, 30 centimeter. So in this case it will be, the radius of curvature will be 40. So my object will be between C and F. Okay, the object will be between C and F. And in third case the object distance is 20. So object distance is 20, so it's between focal length and pole. The object will be somewhere here, 20 centimeter. This is my object, this is my object. Now answer. More the distance from focal length, smaller the image. Quantum is saying case 1. Allah is also saying case 1. Mirror A. Okay. Okay. This is mirror A, B and C. Correct. So as we are at infinity, my object is formed at focus, which is point size. As I come closer, object start getting bigger, but till radius of curvature it says smaller than the image stays smaller than the object, correct? After we cross center of curvature towards focal length and pole, towards my mirror, the image will start getting bigger. So it is correct. More the distance from focal length, smaller the image. That is kind of correct. So in first case the image will be, okay, in first case the image will be diminished, correct? This is the first answer. Let's see the second part. List 2 properties of the image formed in case 2. In case 2, what was the case 2? The object is between C and F. First tell me, where will the image be formed? Where will my image be formed in second case? In case of mirror B. Image formed is virtual, erect and enlarged. Think again. Think again. It is between C and F. Wait a minute. The second case we have 20, 45. I think I just replaced the mirrors. Okay, first one is 20. First one has 20 focal length and second one has 15. This has 15. Okay, my bad. This is 15 and okay, let me correct this. Just a second. They are saying that focal length is 15 and object distance is 30. Focal length is 15, so curvature is also 30 and then object is also at 30. So my object is at center of curvature. Now answer. Still, what will be the answer? In concave mirror, my object is at center of curvature. What will happen when my object is at center of curvature? What will be the nature of image that will be formed when the object is at center of curvature? Okay, so the image formed will again be at center of curvature. We know it will be of same size, correct? It will be of same size, but since it's a concave mirror, it will be real and inverted, not virtual and erect. Okay, it will be real and inverted, correct? Let's see the third part. Third part says, what is the nature and size of the image formed by mirror C? Draw a ray diagram to justify your answer. Mirror C, focal length is 30, object distance is 20. So focal length is 30, object distance is 20 from the pole. So this is my focal length, this is pole, and the object is between, it's between focus and pole, correct? Now they have asked, what is the nature and size of the image? What in this case, what will be the nature and size of the image formed? Let me know in the live chat. What will be the answer to this question, guys? What kind of, where is, yeah. What kind of image will be formed if my object is between pole and focus? So between pole and focus, we know this is a sixth case, which is a exceptional case. So for image, it will be beyond, the image will be beyond the mirror, and it will be virtual and erect, and it will be enlarged, correct? Okay, let's move on to the next part. What the next part says? An object is placed at a distance of 18 centimeter from the pole of a concave mirror. Now we have a numerical. Okay, so the object is placed at a distance of 18 centimeter. It's a concave mirror, focal length of 12 centimeter. Find the position of image. Okay, that's easy. We have a concave mirror. Object distance is always negative and it's given as minus, what it was? Minus 18 centimeter, and focal length of concave mirror is also always negative. So it will be minus 12 centimeter. Correct. Let me know the answer in the live chat. Can you solve this question? What will be the distance of image from pole? Let me know the answers. I have told you to get your pen and paper with you. Okay, keep your pen and paper with you. What will be the distance of image? Let's solve it. We can easily solve it using mirror formula. 1 by F equals to 1 by V plus 1 by U. Correct? Now 1 by V we need to find. 1 by U is minus 1 by 18 and this will be minus 1 by 12. So 1 by V will simply be 1 by 18 minus 1 by 12, which will be, if you take the LCM, this will be 36. 2 minus 3 and the V will be minus 36 centimeter. Correct? Correct. Can we move on to the next question? Okay, let's move to the next question, which says, a narrow beam XY of white light is passing through a glass prism. There is a glass prism and a narrow beam of XY is passing. Trace it on your answer sheet and show the path of emergent beam as observed on the screen PQ. Name the phenomena observed and state its cause. Can you answer this question? Hi Karan. Can you answer this question? What phenomena is being used in this particular case? What is happening here? What is happening here? Can I ask you? What kind of phenomena is happening in this part? See, all these are PYQs. So these are very important questions. You keep solving this. This will get engraved in your memory so that you won't forget it. Okay? Okay, so here the phenomena is happening is actually dispersion. Correct? It's a dispersion of white light. Correct? Dispersion of white light into its 7 constituent colors. And its cause, for cause you can actually write that each color has different wavelength, so they bend at different angles when passing through prism, and that's why they get dispersed into its 7 constituent colors. Correct? Karan, like here we are teaching in English, so that's why we are speaking in English. Okay? Okay. Also they've asked you to trace, so you can just trace what will happen. This is normal, so this will bend towards normal, but it will also split into its 7 consequent colors, and then it will split by coming out. So on screen PQ you'll see a pattern which is whip gear. Correct? Let's move on to the next question. Can we? Okay. The next question, which is 8th question, we are already at 8. Okay, big question. This requires a bit time, so listen carefully. Okay? Hold a concave mirror in your hand and direct its reflecting surface towards the sun. Okay? Direct the light reflected by the mirror onto a white cardboard, and that is held close to the mirror. So what we need to do, we have a concave mirror. The concave mirror is pointing towards the sun, and the light that is reflecting is getting focused on a cardboard. Correct? Move the cardboard back and forth gradually until you find a bright sharp spot of light on the board. The spot of light is the image of sun. So of course we know the rays are coming from parallel, so we need to find a focus, and the point where we get a bright image of sun will be our focus. So that is called principal focus of the concave mirror. Now they have asked you, what is list 2 applications of concave mirror. Can you answer it? Can you answer it? See, you need to write your answers in English as well, right? So if you understand, try to understand it in English, then only you will be able to write your answers in English in the paper. Okay, so that teacher can understand you properly. Correct? Now can you answer me this question? What are the 2 applications of concave mirror? This is very easy. Come on, guys. Always parallel. See, applications. You need to tell me the applications of concave mirror. That is where the concave mirror is actually being used. Okay, so concave mirror, we can say that concave mirror is used in headlights of vehicles, headlights, and it's used in barber shops. Okay, so these can be 2 applications. Correct? Next, if the distance between mirror and principal focus is 15 centimeter, find the radius of curvature of the mirror. So my focal length is 15 centimeter. So the radius of curvature will be what? Just twice of focal length. This is very easy. 2 into 15, that will be just 30 centimeter. So B part is also done. So the C part, draw a ray diagram. Car, yes, headlights of car. Okay, so C part says draw a ray diagram to show the type of image formed when an object is placed between pole and focus of a concave mirror. Now can I trust you guys to make this diagram? If the object is between pole and focus, the image of concave mirror, the image will be formed behind the mirror, that will be virtual, erect and enlarged. Correct? So you have to solve this by yourself. Okay, D part says an object 10 centimeter in size. So we have an object which is 10 centimeter in size. So height of object is 10 centimeter. Then is placed at 100 centimeter in front of a concave mirror. So I also have a concave mirror, and it's given that the object is placed at 100 centimeter. So object is always negative. So can I write minus 100 centimeter? Then if this image is formed, what it says, if the image is formed at the same point where the object is located, find the length of the mirror. They are saying if my image is also at minus 100 centimeter, then what will be the focal length? So do you want me to solve it by hard work or cleverly? Very easy, okay? I am very glad that you are finding these numericals easy, because these are actually one of the finest numericals that have come in your boards previously. Okay? Okay, so you can just use, you can either use mirror formula, okay, that will be 1 by u plus 1 by b, but we are not going to use it. We are going to solve it cleverly. Okay, so object is at 100 centimeter, v is also at 100 centimeter. So this will be what? This will be my radius of curvature or center of curvature. Correct? So R is 100 centimeter. Correct? If you want to write minus, you can write. So focal length will be what? It will be just half of R. That will be minus 50 centimeter. Correct? When the object and image distance is same, it is same at center of curvature. If my center of curvature is 100 centimeter, focal length will be half of center of curvature. So focal length will be 50 centimeter. Correct? They have asked one more thing. Magnification of the image formed with the sign as per Cartesian convention, new Cartesian convention. Okay, so we have V by U, and we know the formula of magnification is what? It's mirror. For mirror, it's minus V by U. Correct? Minus, this is minus 100 divided by minus 100. So this will be, magnification will be minus 1, which means the object is of same size. Correct? And this negative sign, it means it's real and inverted. Correct? Can we move to the next question? Okay, moving on to the next question. 9th question, it says that absolute refractive index of glass and water is given if the speed of light in glass. Okay, so we are given with refractive index of glass as 3 by 2, refractive index of water as 4 by 3, and the speed of light in glass, so Vg is what? 2 into 10 raised to power 8 meter per second. Correct? Then the speed of light in water, we just need to find the speed of light in water. Can you solve this question? Can you solve this question, guys? What is Cartesian convention? These are Cartesian coordinates, okay? According to some rules, we have some Cartesian coordinates so that everyone can use it just like that. That means U is always taken as negative. We will depend on the position of image, on the position of, on the position of image, okay? So those are Cartesian coordinates. Let me know the answer. This is just simple numerical question. You have values, you have formula. You just need to remember what exactly the formula was. Okay. So refractive index is inversely proportional to velocity. We know that. So we have glass divided by n of water. That is correct. It will be speed of light in water divided by speed of light in glass. Correct. Till now, easy. Now, for glass, it is 3/2. For water, it was 4/3. And we need to find VW. And this is given, that is 2 into 10 raised to power 8. So, V of water will be 9 divided by 8 into 2 into 10 raised to power 8. This will get cancelled. So our answer will be 9/4 into 10 raised to power 8 meter per second. Which option is that? We have A. Correct? Understood, everyone? Everyone understood the question? You were given refractive index of glass, water, and you needed to find the velocities. You were also given velocity of light in glass, and you needed to find the speed of light in water. Correct? I'll just say complete the NCERT first. But if you have completed the NCERT, then you can go for question bank and previous year mostly, okay? Analyze your previous years first so that you can get a gist of what kind of questions CBSE asks. Maybe don't go for too hard questions. That will be just a waste of time. Analyze your PYQs first, and then you can see what kind of questions you can do. First NCERT, then PYQs, then some question bank. Okay? Okay. Let's move on to the next question. The question says, the variation of image distance with object distance for a convex lens. This is a convex lens is given. Analyze it and answer the questions. This is some table that you are given. This is object distance, image distance, and the lens is convex lens. This is my convex lens. Okay? Now, they are asking without calculation. You don't have to show the calculation. Without calculation, you have to find the focal length of convex lens, and then you have to justify your answer. Can you answer this question? Can you answer this question, that what will be the focal length of this convex lens? So what you have to do basically is, you have to see, this is my object distance, this is my image distance. Read everything carefully, then you will realize that in this case, the object distance and image distance is same. So if object distance and image distance is same, that means the object is at where? It is at center of curvature. So if my center of curvature is 50 centimeter, if it's 50 centimeter, then my focal length will be what? 50 divided by 2, that is 25 centimeter. Correct? No need for calculation, just a clever brain. Okay? Correct? Now, second question says, read it carefully. Which observation is not correct? Which observation is not correct? Why? Draw a ray diagram to find the position of image formed for this position of the object. First, you have to tell me which of the observation is not correct. Can you see? Yes, center of curvature. Can you tell me which observation is not correct? See the table carefully and let me know which calculation is not correct. Would it be what? Let me know which calculation is not correct. It's a very, very tricky, plus if you know, it's very easy. It's very clever question, and you have to be clever to answer this question. Read the table carefully, very carefully. I think 4. Okay. Karan is saying 4th is incorrect. Okay. Can you tell me the reason why? Can you tell me what is the reason exactly? Anyone else? 6. Sanu is saying 6. Okay, we have 2 answers now. Let's see which one of you is correct or not. Okay, so if you analyze this table carefully, you will see some anomaly. At 75 centimeter, if my object is at 75 centimeter, the image is formed at 37.5. But at minus 15 centimeter, the image is again formed at 37.5. Okay, now what you can do is, you should analyze these 2 cases carefully, correct? The focal length is 25 centimeter. In first case, the image distance is here. It is at 75 centimeter, correct? Now, in the 6th case, the image is 15, the object is at 15 centimeter. That is, it is between focal length and pole, correct? Oh, sorry. This image will not be on this side. This image will be on the other side. Okay, so what did I do? Okay, it was correct. This is at 75. Now, this is my object in 2nd case. This is my object in 6th case. Which of this is wrong? Now you understand, right? How you will see that? You will also see the signs of these images. If my object is between pole and focus, then the image should be on this side of the mirror, correct? On left hand side of the mirror, correct? Lens. So what we'll do, for left hand side, its plus sign should be what? Negative. If my object is between pole and focus, the image should also be on that side of the lens, and on this side of the lens, we know the distances are taken as negative, correct? But here it's positive. So that is our clue that this is the wrong answer. It's fine. You just keep trying, and when you do these questions, that's why we have got you all these questions. So you can practice, and your mind will say, okay, this is the question. I should be careful at this point. Okay? Understood now? It's fine. Okay. Now, the other part, it says, find the approximate value of magnification for u equals to 30 centimeter. For u equals to 30 centimeter, we need to find the approximate value of magnification. So see, magnification for lens was v by u. We have u which is given as minus 30 centimeter. But we just found the focal length which was 25 centimeter. Correct? So, can we calculate v from this? Exactly, ma'am. We can use lens formula. So, 1 by f is 25 and 1 by v we need to find minus 1 by minus 30, which will just, if we take it here, 1 by 25 minus 1 by 30. Correct? Understood? Everyone? Can I trust you guys again to do the calculation of this? You will just get v and then you'll put it in the magnification formula and you will get your answer. Correct? Okay. 1 by v will be just, it will be 750. If you do 30 minus 25, 1 by v will be 5 by 750. Are the signs correct? The signs are correct. And 1 by v will be, this will be 150. Okay, and 150, so v will have 150 centimeter. And then we'll calculate magnification. V is 150, u was 30. So this will be 50. Correct? Let's move on to the next question. I am Maharashtra board student. It's fine. Your concepts, your formulas for all the boards for 10th class will be same, and even if you practice all these questions, you will get benefit for your state boards as well. Okay. Now I want you to join your WhatsApp channel, join our WhatsApp channel, and hi Jay Solanki. Join the WhatsApp channel. You will get all the updates, all the notifications for all the subjects. We are going live every day, twice, and we are giving you all the question banks. Okay, all the important questions for your pre-boards, for your boards. You will see all the notifications. You will get the PDFs of these questions, and go follow the channel, join the channel, subscribe this channel, and like this video. Okay, we are moving on to the next chapter, that is human eye. Go like this video right now first, so that we can go ahead. Okay, let's move to the next question. This is human eye. Okay, it is observed that the power of an eye to see nearby objects as well as far off objects diminishes with age. Okay, give a reason for the above statement. What is the reason for the above statement? Can you give me the answer to this question? What will be the answer to this question? It is observed that the power of an eye to see nearby objects as well as far off objects diminishes with age. What will be the reason for this statement? Presbyopia. Very good. Sanu is saying presbyopia. That is correct. So with age, what happens? If you've seen your grandparents, they might read the newspaper like this, and they won't be able to, probably they won't be able to see far off objects clearly. So what happens with age? That their lens or their ciliary muscles gets weak, and that's why it couldn't hold the lens in place properly, and the lens is not able to make the image properly on retina. Correct? That is called presbyopia. It is called presbyopia. Name the defect that is likely to arise in the eyes in such a condition. Okay. And the reason we also stated. Correct? The reason was weakening of ciliary muscles. Correct? Let's move on to the next question. It says, define the term power of accommodation of human eye. Can you answer this? It's very easy. Power of accommodation of human eye. Can you answer? Can you answer this question? Power of accommodation of human eye. So basically the power of, are you guys writing? Should I wait or I'll explain the question? Okay, it is corrected by using bifocal length. Okay, first let me know what is the power of accommodation of human eye. Was there any other? Yeah, okay, of course. The presbyopia, it is corrected by using bifocal lenses. Correct, Sanu, very good. Now, can you give me the answer of power of accommodation of eye? Okay, let me just tell you its theory. So, power of accommodation of human eye is just basically, yes, we have got the answer. The capacity of lens to change its focal length as per need is called power of accommodation. That is absolutely correct. Our lens is very, what do you say? It can change its shape very easily. It's very flexible. So it can get thick, it can get thin according to the objects we are seeing. It can change its focal length. Hi Abhimanyu. Okay, So we are seeing a question, power of accommodation of I. Sanu has replied very great. The capacity of lens to change its focal length according to the need, it's called power of accommodation of eye. Okay, what happens to the image distance in the eye when we increase the distance of object? This is eye, okay, and this is, okay, that is a bad eye. This is an eye, and this is my retina, okay. This is where the image is formed. Now they are asking what happens to the image distance in the eye when we increase the distance of object. Does it change? Can you answer this question first? After that you can see where are you. Ask each other, where are all of you from? What happens? This is a very important question. Listen carefully. My image distance is not changing or it is changing. You have to let me know what happens to the image distance of the eye when we change the distance of object. If the object is here or it's here, does the image distance change or not? Sayar is saying no. No, it changes, or no, it does not changes. If my object distance changes from my eye lens, my image distance won't change. Why? Because the image is always formed at retina, and my eyeball, my lens is definitely changing shape, or it's definitely changing shape or focal length, but my image distance remains same, correct? Because this is the lens and this is the eye. Until there is some change in the eyeball length, the image distance won't change. And we studied in defects that the length of eyeball can only change due to some accident or maybe age related issues, okay? In normal circumstances, the image distance remains same. Name and explain the role of part of human eye responsible for it in this case. Can you tell me the answer to this question? Which part of human eye is responsible for keeping the image distance same? Can you answer this question? My lens is getting thicker or it's getting thinner. That is the only reason why the image distance can remain same and the image is always formed at retina. What part of human eye is helping to do that? Iris, Karan is saying. Eye lens, Sayar is saying. Okay. Eye lens can be an answer, but I want you to think it carefully. What is controlling the eye lens? Eye lens alone can't do it. Some muscles are making the eye lens to change its shape. Ciliary muscles, exactly. Sanu said ciliary muscles. So my eye lens can change shape and let the image be formed on retina only and only because my ciliary muscles are there. Correct? The ciliary muscles are there, and because of these muscles the lens can change its shape and hence image is always formed at retina. Correct? Let's move on to the next question. Yes, it's ciliary muscles. Yes, ciliary muscles is the correct answer. Let's see the third question, which says define power of a lens. See, in this human eye chapter you will get questions, one or two parts like this. What is power of accommodation of eye? What is the power of a lens? Okay, so you need to remember some small definitions like this. Let me know in the chat. What will be the definition of power of lens? Read it carefully. Karan is asking what is the function of iris. Okay, so iris is basically the part of eye which gives the color to your eyes is iris. So what it does is, pupil is what control how much light enters into our eyes. Iris helps the pupil to shut down or increase, to get enlarged or get smaller according to the requirement of our eye, according to the light present. So iris helps pupil onto how much light it should get into its eye. Ma'am, you're only using, yes, we teach you in English, Sayar. Okay, yes, okay. Power of lens is basically the ability of eye lens to converge or diverge the light rays. Okay, so this is a lens. If it's thicker, it can diverge the light rays closer. If it's thinner, the light rays will be diverged a little backward, okay, because the focal length is here, its focal length is here. So the ability of a lens to diverge or converge the light rays is called power of a lens. Correct? Now, the focal length of lens is 10 centimeter. It is given that there is a lens and focal length is 10 centimeter. Write the nature of the lens and find its power. We need to find the power. If my focal length is positive, which lens, concave or convex, has positive focal length? Can you give me the answer to this question? Focal length is 10 centimeter. Just tell me it's a positive value. Which lens, concave or convex, has positive focal length? Can you tell me? Concave or convex? Which lens has positive focal length? Okay, so according to my understanding or the 10th class understandings, focal length for concave mirror as well as lens, focal length is always negative. Focal length is always negative. So for convex lens, focal length is positive. And for power, we can use the formula, that is 1 by 10. Now, remember this is in centimeter. So for power, you have to convert it in meter, which will be into 10 raised to power minus 2. Now this is in meter and this will be 10 diopter. Correct? So power is 10 diopter of this lens whose focal length is 10 centimeter. Convex, Abhimanyu said, very good. Ma'am, if student issue is not clear, why student is class? What issue is not clear, Karan? Can you tell me what is the issue? Okay, so you are asking me to explain in Hindi. See, on this channel, we only teach you in English, so that you can understand in English and you can write in English the paper as well. Okay? Correct? Can we move to the next question? Or this question is complete or not? Okay. Now they're asking, if an object is placed at a distance of 20 centimeter. Now this is given that my object is placed at a distance of 20 centimeter. Then from the optical center of this lens, according to the new Cartesian sign convention, what will be the sign of magnification in this case? We need to find the sign of magnification in this case. U is minus 20 centimeter. Minus 20 centimeter. My focal length is given as 10 centimeter. It's 10 centimeter. Okay. The focal length is 10 centimeter. Now, you can again find the value of V, or you can be a little bit clever. Okay, is my voice not coming properly? Can others let me know? Am I not audible enough? Just let me know if my voice is clear or not. Is it loud enough for you guys or not? Shant is saying not loud. Anyone else? Voice is okay. Abhimanyu is saying. Okay. Yes, correct. Sanu said M is H2 by H1 equals to V by U. That is correct. We just need to tell the sign of magnification. So what you can do is, in this particular case, we have a convex lens. Correct? We have a, in this case, we have a convex lens. And for convex lens, the object is placed beyond the focal length. The object is somewhere here, 20 centimeter, and the focal length is 10 centimeter. Correct? In here, the focal length is 10 centimeter. So if object is beyond focal length, then my image will be on this side of the lens. So the sign of image will be positive. Correct or not? This will form a real inverted image. If the object was between focal length and pole, then the distance will be, then the image will be virtual, and if image was virtual, we will be negative. But in this case, the object is beyond F, or we can say at center of curvature, so the image will be formed on this side of the lens and its sign will be positive. So I have the signs. This is V by U. V is positive, U is on the other hand negative. So from this we can say that sign of magnification will be negative. Correct? Understood? My one student. Okay, let's focus on your questions and not some random. Okay, what is a rainbow? Draw a label diagram to show its information or its formation. Okay, can you tell me what is a rainbow? If you don't want to study and ask random questions, you can leave the class. Can you tell me what is a rainbow? Don't create such nonsense in the class. You are kids, stay like kids. Can you give me the answer of what is a rainbow? It's a 7-color line. Okay, Karan, like be more, you can be more, so you have to be more specific. Okay, when you are defining what a rainbow is, you have to be a little more specific. Like it's a rainbow, we know is a natural phenomena. So you can write that rainbow is a natural phenomena which happens. Why rainbow is being formed? Rainbow is being formed due to dispersion of white light into 7 colors, correct? And inside the water droplets that are forming the rainbow, we have internal reflection happening and then refraction, correct? How can you write the answer? You can write that a rainbow is a natural spectrum of sunlight formed after rainfall, obviously due to dispersion, internal reflection and refraction of sunlight by water droplets, correct? Prism, Vikas, right? Prism is not the answer on what is rainbow, okay? Prism is a different concept. Rainbow have color Vibgyor, correct, formed in air. You can write kind of all these things, but you have to be specific for a one-liner which says it's a natural spectrum happening because of dispersion, internal reflection and refraction due to tiny water droplets. Correct, sir. You are also correct. Meteorological phenomena you don't have to write in your exam. Okay. It is not a meteorological formula. Okay, correct? Understood everyone? Then draw a label diagram to show its formation. What you have to do, just draw a tiny droplet. This is the sunlight that is coming. So what you have to do, this will get dispersed into 7 colors, correct? 7 colors. Then total internal reflection will happen, okay? And then the light will come out, and from here you will see the eye. It's a great eye, by the way. Okay, and this will be WebGear. WebGear. Okay, correct? So the white light splitting into 7 colors due to water droplets is why rainbow happens. Okay, let's move on to the next question. Name the type of lenses required by the persons for the correction of the defect of vision called presbyopia. We need to answer what kind of lenses are corrected to correct presbyopia. Can you answer this question? What kind of lenses we use to correct the defect called presbyopia? Meteorological, what is it, ma'am? Okay, convex, Karan is saying. Bifocal, Sanu is saying. Let's see who's correct. Meteorological, there are so many meteors in our solar system. So because of those meteors, we have some phenomena on Earth if it enters into our system. So because of that, we call meteorological phenomena, and that is not why rainbow is formed. Okay, this correct presbyopia. For presbyopia, we use bifocal lenses to correct this defect of vision. Write the structure of the lenses commonly used for the correction of this defect, giving reasons for such design. Convex lens is used for hypermetropia. In presbyopia, you have to use both convex and concave lenses. Why? Because in presbyopia, that person is not able to see nearby as well as far object clearly. If we just use a convex lens, he still won't be able to see concave lens far objects clearly. Okay, he will be able to see nearby objects clearly, but not the far ones. For far ones, we have to use concave lenses. So this is the kind of structure we use for presbyopia. It's called bifocal. This part is concave lens, the under part is convex lens. Convex lens is used while reading, so that this part is convex. So I am reading like this, so I can use the lower part of the eye, and if I am looking far away, that will be the time I'll be using concave lens. Okay, upper part is concave, lower part is convex. Correct, very good. Let's move on to the next question. Okay, again I want you to remind, go join our WhatsApp channel. You will get all the notifications there of all the live, and we are bringing you a free crash course on YouTube very soon. So be ready for that. A big thing is coming. We will prepare you for CBSE boards, and you will score more than 95 plus. Okay, and it will be for all the subjects. So go join the WhatsApp channel, subscribe this channel. Okay. Next question says, just an MCQ is very easy. The image distance from the eye lens in the normal eye when we increase the distance of object from the eye. This is actually something I asked you before as well. Can you answer this question? If the image distance, what will be the image distance? How will it change if I increase the distance of object from my eyes? Will the image distance remain same or will it change? Let me know in the live chat. Come on guys, you are doing really great actually. I am not ignoring you, but you have to be selective of the content you are consuming. So if you want to say things like this, you will get ignored from me and from maybe other people as well. C, Karan is saying C. Okay, anyone else? J. Solanki is saying B, that it decreases. Let me just remind you to read the question carefully. This is a normal human eye, not just a lens. It's a human eye. Don't worry about me, just answer the question. Okay, let's see who's correct, Karan or Jay. Yes, for Karan is correct actually. So again, while we discussed it earlier, I told you that my retina, this is the screen, this is my, not my, but this is a human eye, this is retina. So from this lens, the distance of retina is always remains, the distance of retina from the eye lens remains unchanged. Okay, it's the same. So even if my object moves to infinity or it is here, the image distance will not change. So the answer is C, it remains unchanged. Very good. Okay, 7th question. It says, after tracing the path of a ray of light through a glass prism for 4 different values of angle I, every ray diagram was analyzed and the following conclusions were drawn. A. On drawing the prism, the ray bends towards its base. So they are saying, this is my prism, light enters. Where does the ray bends? Towards the base or away from the base? Okay. B option is, while emerging from the prism, the ray further bends towards its base. So while coming out of the prism, it is also bending towards its base. And the C option is, the emergent ray bends at a certain angle to the direction of incident ray. This emergent ray bends at a certain angle from the emergent ray. Which of these is true? Can you tell me which of these 3 statements is true? Which of these statements is true? The ray will bend towards the prism while entering the prism, and then will it bend away or towards the prism while emerging out of the prism, and they are saying the emergent ray bends at a certain angle to the direction of incident ray. One is true. Karan is also saying one is true. I want you to read carefully. Someone said B. Why did you delete it? Okay, actually whoever said B, I was not able to see. Yes, Sanu. Sanu said B. That is actually correct. The no. Wait. Think again. B. Which of these statements is correct? Okay, let's just draw a prism. Okay, this is my prism. Okay, this is a ray coming, and when it enters into the prism, this is the normal, so it bends towards the normal. So instead of going straight like this, it's bending, and it's bending towards the base. Correct? It's bending towards the base, and then here when it's coming out of the prism, it goes away. It goes away from the normal. So let me know now which answer is correct. But ma'am, their option has given. Okay. Now tell me which one is the correct answer. Now I told you what kind of image, what kind of path does the ray follows when it enters into the prism and goes out? Let me know. Okay, actually the answer is 4. That is, all of these are correct. How? Now we have seen that ray is coming and it bends towards the base. So first is correct. While emerging from the prism, the ray further bends towards the base. That is also correct. It's bending towards the base, right? Then the emergent ray bends at a certain angle to the direction of the incident ray. So this is my incident ray, right? If it goes, it is an incident ray and it goes back. So this is called angle of deviation, right? We have studied it. It's called angle of deviation, and it does mean that the emergent ray bends at a certain angle to the direction of incident ray. We are not saying it's bending from the incident ray, from the direction of incident ray. So all these are correct. Okay, A, B and C all are correct. Okay, 8th question. The sky appears dark to passengers flying at very high altitudes, mainly because option A is scattering of light is not enough at such heights. There is no atmosphere at great heights. The size of molecule is smaller than the wavelength of visible light. The light gets scattered towards the earth. What is the correct answer? A, B and C correct. All 3 are correct. Exam में तीनों correct लिखना है. Yeah, it's fine. If you are not seeing option 4, just don't, you can do these kind of silly mistakes in this question series. That's why we have put so much effort in these series, so that we can bring you so many questions, so that you can do all the mistakes here only, and there are no lets to make in your exam. Okay, Karan is saying C. The size of molecule is smaller than the wavelength of visible light. J is saying D. The light gets scattered towards the earth. Anyone else who wants to answer? Okay, the answer, however, actually is A. At great heights, as the light is coming towards Earth, there are molecules increasing. As the atmosphere particles increase, or the molecules increase, the light gets even more scattered. So at such heights, there are 100 molecules, and as you come in between, there are also molecules and particles, right? So the light keeps on scattering more and more. So at great heights, the light is not that much scattered. There are molecules, there are particles, but the light, obviously, if the light is scattering from 100 particles, it will be a bit brighter, darker than if it is scattering from 200 or 300 particles, correct? So at great heights, there is not much scattering. So A is the correct answer. Okay? Next question. Let's move on to the next question. 9th question we are at. We have just 2 more questions left. Give it your best. Okay. The near point of eye of a person. Karan is saying, what didn't you get properly? See, this is my atmosphere. Okay. There are certain particles. There are then certain particles here, then certain particles here. If the light gets reflected here, it will get reflected once, and then here it will get, not reflected, scattered. It will get scattered once, twice, thrice, 4, 5, 6, 7. And as the scattering increases, the light gets more scattered, and hence more blue color is visible than the darker colors. But here the scattering is not enough. Okay, there is just 1 or 2 scattering according to this, let's say. So the scattering is less colors are scattered, so the light is dark. Correct now? Understood? Okay. Let's move on to the 9th question. The near point of the eye of a person is 50 centimeter. Find the nature and power of the corrective lens required by the person to enable him to see clearly the objects placed at 25 centimeter from the eye. Can you focus on the question? What is the corrective lens that is used in this case? Okay, let's understand this question a little bit. They are saying the near point. Now, the near point is basically of a normal human eye is 25 centimeter. We know that. But they are saying that in this case, the near point is 50 centimeter. Correct? Find the nature and power of the corrective lens required by the person to enable him to see clearly the object placed at 25 centimeter. So, the object is placed at 25 centimeter. This is clearly given. So, if I have a near point of 50 centimeter, but object is at 25 centimeter, so my lens should make the image at 50 centimeter first, then only my eye lens will be able to see it properly, right? So, for the corrective lens, the image distance is 50 centimeter, correct? The image distance is what? 50 centimeter. Now, what is this defect? This is what? Hypermetropia, because the person is not able to see clearly at 25 centimeter. That means he is not able to see nearby objects clearly, and for nearby objects, the defect is called hypermetropia. And the kind of lens that is being used to correct hypermetropia is what? It is convex lens. Correct? It is what? It is convex lens. Understood? Focus on the question, guys. Did you understand till here? Okay. So now in case of convex lens, V is also negative. So they want us to find the power. To find power, we first have to find focal length, correct? So using lens formula, this will be 1 by V minus 1 by U. So 1 by focal length will be minus 1 by 50 minus of minus 1 by 25, correct? Which will be, if you just solve it, this will be 1 plus 2, 3 by 50. Is this correct? No, this will be minus 1 and this will be plus 2. So 1 by 50. Correct? So focal length will be 50 centimeter. Correct? Understood till here? Is everything clear? Everything is clear or not? And you can also see that focal length is positive. So for convex lens, we know that focal length is positive, and hence we can see that this answer justifies our reasoning. Okay, this is correct. Now to find the power, first focal length is in 50 centimeter. We have to change it into meter, which will be 0.5 meter. So focal length will be 0.5 meter and power will be 1 by focal length, that will be 1 by 0.5, that will be 2 diopter. So power of convex lens to correct hypermetropia will be 2 diopter. Correct? Okay, focus on the question, guys. Just one question is left. A student needs spectacle of power 0.5 diopter. We are given that power is minus 0.5 diopter for the correction of his vision. Name the defect of vision the student is suffering from. Do you know how to solve this question? You know how to solve this question? Let me know. what will be the defect of vision this person is suffering from. Okay, let me just tell you how to think about for this question, what should be the right approach that will also save you time. Okay, so power is in negative, the focal length hence will also be in negative, and focal length is negative for concave lens, we know that, correct? And concave lens is used to correct which defect? It is used to correct myopia, correct? Understood the chronology? Everyone understood? Now understood, Karan? Is it true? Is it correct? Did you understand? Power is negative, so focal length and power has same sign. So focal length is negative. Focal length is negative for which kind of lens? It is concave lens, and concave lens is used to correct which defect? It is myopia, correct? Hi Rishik, correct? Now the second part they ask is find the nature and focal length of the corrective lens. So we can easily just find the focal length by through power. Power is minus 0.5, which is focal length. So focal length will be minus 1 by 0.5. Focal length will be minus 2 meter. Correct? Focal length is just 1 by power, 1 by 0.5 negative, and that will be minus 2 meter. Understood? Then the third part, list 2 causes of this defect. So for this defect, for myopia, either the in this case, okay, first let me, in this case where the image is formed for myopia, in front of the eye or behind the, sorry, in front of retina or behind the retina, where the image is formed. Let me know in the comment section. Hi Ajinkya. Let me know in the live chat. I'm waiting, guys. It's very simple. Where is the image formed? Okay, Karan is saying front. Yes, elongation of eyeball can be a reason. Correct. Okay, Karan is correct. So in this case, I actually started writing the answer. So 2 causes is elongation of eyeball, or the second will be what? Decrease in focal length of eye lens. Correct? Decrease in focal length of eye lens or elongation of eyeball. Correct? Front of retina, Avika also said front of retina. Very good, everyone. Okay. Great, guys, that is it. We are done with 20 most important questions of our chapters light and human eye. If you want other 2 chapters of physics that are also there on our channel, you can go check them out. That is also alive, so it will be a bit interactive. You can go check those out too. So there are total 40 questions I have given you. Those are complete most repeated PYQs that you can definitely solve, definitely study for your pre-boards as well as your boards. Correct? Okay, that is it for this live, guys. We'll meet. We are bringing you a crash course really soon, and for that you can join our WhatsApp channel. You can join our WhatsApp channel, okay? You will get all the notifications, what is happening, when it is happening, all the videos that we are making for you guys. There are model question papers solved on our channel, all the one-shots, all the numerical videos. You can go check them out. And I want you to subscribe this channel, and if you are here, like the session. Okay. Okay. Bye guys.